So good evening students. Till now in the optical fiber communication we discuss about the optical fiber communication system. After that the communication losses, and then sources and detectors, etc. And right now we are moving towards the unit number 4, which is based on the optical amplifier. So first one, which, what is the use of optical amplifiers? So optical amplifiers are used to boost up the optical signal without any conversion of the light into an electrical signal. But if we talk about the electro-optic regenerator, so in the electro-optic regenerator, we first receive the optical signal, then convert it into electrical signal, and then we amplify it, and then again we convert this electrical signal to the optical signal and then transmit it. But in the optical amplifier, we just amplify the optical signal and then transmit the optical signal. There is no need to conversion. So first of all, that why to use optical amplifier? So there are a decay in the optical power due to the various factors such as fiber attenuation and the connector losses, and the wavelength division multiplexing components also have some attenuation, and then couplers which are used to couple the optical fiber and another devices, they also produces some losses. So we use the optical amplifiers and repeaters in the network. So the classification of optical amplifiers according to the applications are, first one is the inline amplifier, then pre-amplifier, then a booster amplifier, and the lane booster amplifier. The position of these all type of amplifiers are at different places. If we talk about the power booster amplifier, then an inline amplifier, then they are near the transmitter. And if we talk about the pre-amplifier, then pre-amplifier is near the receiver. Then this is the definition of pre-amplifier and power amplifiers and the line amplifiers. Now the basic term which is used here, the optical amplifiers. So in the optical amplifiers, we first take the input of optical signal, which is very weak in nature. Then we amplify it by using the pump power, and then the amplified signal is again transmitted, or we can say the optical signal output from the another end of that optical amplifier. Now the type of the optical amplifier, there are two major classification of the optical amplifier. The first one is the semiconductor optical amplifier, that is SOA. Second one is based on the fiber optical amplifier, that is FOA. The FOA is again classified into the two type of amplifiers. A is a rare earth doped fiber amplifier, and B is a fiber Raman or the Brilliant amplifiers. These rare earth doped amplifiers are EDFA, TDFA, and PDFA based on the CL band, S band, or O band. Now the basic principle of SLA is stands for the semiconductor laser or optical amplifier. So first of all, we have to remember some of the concepts of the laser diode. Suppose that the diode laser has no mirrors. We get the diode to a population inversion condition. We inject the photons at the one end of the diode. Then by stimulated emission, the incident signal will be amplified. Then by stimulated emission, one photon give rise to another photon. The total is two photon. Each of these two photon can give rise to another photon. The total is then the number 4, and it goes on and goes on. Okay. So what is the problem with this type of semiconductor laser amplifier? Are the first one is the poor noise performance. They add a lot of noise to the signal. Second one is matching with the fiber is also a problem. Suppose you have to create a coupling in this. So it will create a lot of problem due to the matching. After that, they are small and cheap. However, they are small and cheap, but this is an advantage. And after that, they are highly polarization sensitive. They can produce several crosstalk when multiple optical channels are amplified. So these are the problems and some advantage of the SLA, that is a semiconductor laser optical amplifier. So we use SOA, that is a semiconductor optical amplifier. The structure of SOA is similar to that of the semiconductor laser amplifier. It consists of an active medium that is called a PN junction. It is the P type, it is a N type in the form of a waveguide, usually made of indium gallium arsenide or indium gallium arsenide phosphide. Energy, and then when we talk about the energy, then the energy is provided by the injecting electric current over the junction. So this is a current pump. So it is so here we can see that the weak input signal, and here the amplified output signal. In between there are anti-reflection coating. Here is also a anti-reflection coating. This is the p-type material, this is the n-type material, and this is the active region, or we can say the optical amplifier. And here we can see the current pump. So it is basically structure of a semiconductor optical amplifier. After that, the semiconductor optical laser amplifier and SOA. So the design principle, or we can say the example of a SOA design. So here it is a mirror, it is a partial mirror. If we talk about this active region, then it is look like this amplifier. Here we use the anti-reflection coating for the um, for the amplifier designing. Suppose this is another designing. This is a tapered fiber number 1. This is a tapered fiber number 2. This is a waveguide, and it is a semiconductor laser chip at this side, and it is an entity reflection coating. As we can see here, this is the entity reflection coating. So here we can see also the anti-reflection coating. Now the SOA advantages, that what are the advantages of the semiconductor optical amplifier? So first one is the compactness, and second one is the integration potential, high power output, broad choice of operating wavelength, that is about 400 to 2000 nanometer, which is a very broad window. After that, the low price with high volume production. And some disadvantages of SOA are high coupling loss, then polarization dependence, high noise figure as compared with the EDF. The various SOA application are the amplifier, that is a power booster, and then the optical switch element and the wavelength converter. Then the fiber and semiconductor amplifiers have the different properties. The first one is the fiber amplifier, that is they takes energy from the lasers, like the Raman amplifier, again defined by the pump wavelength. That then semiconductor amplifiers energy directly from the current, need fiber coupling losses are very high, and the gain polarization dependent. Another parameter and another type of fiber amplifier we will discuss later. So thank you so much for now.